Now let's go over optimization problem type 3. As we have covered up problem 1 and 2 already, we'll move on to problem type 3 now. This problem is regarding optimizing revenue. We need to read the question first in order to understand what the question is asking us to find out. A commuter train carries 2,000 passengers daily from a suburb into a large city. The cost to ride the train is $7 per person. Market research shows that 40 fewer people would ride the train for each 10 cents increase in the fare, and 40 more people would ride the train for each 10 cents decrease. If the capacity of the train is 2,600 passengers, that's the maximum capacity of the train, and carrying fewer than 1,600 passengers, this is the minimum capacity of train, means cost exceeds revenue. So if it's less than 1,600 people, the commuter train cannot survive, means the business cannot survive. So it's no point taking less than 1,600 passengers. What fare should the railway charge to get the largest possible revenue? Now, since the railway wants you to find out, or this question wants you to find out largest possible revenue means they want you to optimize revenue. Whatever we need to optimize, we need to make sure that we write down that equation. So we will be finding revenue equation. As you all know, revenue is nothing but number of passengers and cost per passenger. So you will be taking the product of number of passengers and cost per passenger in order to find out your revenue. In this case, number of passengers that take the train is 2,000 and cost per passenger is $7. We don't have to touch this equation. All we have to do is, because this is already a constant equation, they say if there are some changes made in the equation, and how do we make those changes is that if we increase the fare by 10 cents or if we decrease the fare by 10 cents, then the number of passenger change will bring up to 40. Either it will increase 40 or it will decrease 40. So out of these two conditions, we can take any one condition, like 40 fewer people would. Since our goal is to maximize revenue, we need to find out the variables for this revenue equation, and the variable will come from this information. They say market research shows that 40 fewer people would ride the train for each 10 cents increase, and 40 more people would ride the train for 10 cents decrease. So let's use any one of this information. It's always better to, it's up to you, but I'm going to be using the first part of this information. 40 fewer people would ride the train for each 10 cents increase in the fare. That means your fare or your cost part is going to be increased by 10 cents, and the number of people part or the number of passenger part is going to be decreased by 40. So the new revenue equation is then going to be in terms of X, where X is going to be the number of change that would bring up. So here 40 times change is going to come, and here 10 cents times change is going to come, and here the change is going to be that you're going to be increasing the fare, so it's a plus 10 cents times X. Here the change is the number of passengers is going to decrease, so it's going to be minus 40X. So once we get this revenue equation, we see this equation is in terms of X. If you want, you can expand the equation. And if we expand the equation is going to come in the form of quadratic equation. So after expanding, we would be able to get this equation in this form. So this is our standard form of quadratic equation. We have got our final equation that we have to optimize. Our next step is to find out the domain. To find out domain, we'll see what variable is this equation in, and this equation is in the form of X. So what does X stand for? X represents the change in fare and number of passengers. We have to limit this X, and the value of X can only be found out by finding if there is any limiting value, and the limiting value comes from the number of passenger limits. Maximum number of passengers the train can carry is 2,600, and the minimum number of passengers the train has to carry is 1,600 passengers. This is our passenger bracket. All we have to do is you just have to make sure that this passenger bracket is always greater than 1,600 for this equation to keep working, or this passenger bracket should always be less than 2600 passengers for this equation to keep working. So we'll take both conditions one by one. Let's keep 2000 minus 40x first greater than equal to 1600. If we put it here and we try solving this equation, this is how the equation would look like: 1600 minus 2000. And now I isolate my x. I get minus 400, which means my x is going to be equal to, because I'm going to be dividing by a negative and this is an inequality, so the sign of inequality flips and I'm going to be left with minus 400 divided by negative 40, which is, so my x should be less than equal to. Next part of the domain comes from, so this is just one side of the domain, we don't have the other side yet, so that would come by putting this equation 2000 minus 40x less than equal to 2600. If I do that, the equation is going to look like this. I would have 600 here minus 40x. Again, I have to divide by a negative number, so this sign is going to flip. When the sign flips, this is how it looks like. It's 600 divided by negative 40, and that gives me x should be greater than negative 15. So combining these two results, my lower limit on my domain is negative 15 and my upper limit on domain is positive 10. I've got my domain. Now once I get the domain, the next part of the question comes from, or the next part of the answer, what do I have to do is I have to now optimize my revenue, and to optimize revenue I have to find out my revenue derivative. So I'm just writing my revenue equation here. I'm going to find out the derivative of revenue, and this is going to give me this equation. Then in order to find out the critical numbers, I'm going to put my revenue equation equal to 0, and my critical number is going to be 80 divided by negative 8, which is, I will use my three values. So one is my critical number, that's negative 10. Another one is my domain, and my domain, this comes from my domain, and this value comes from my domain as well. So this comes from domain. Using this information, I'm going to be finding my final step, that is my final optimized revenue. So I'm going to put in my x values into my revenue equation, and my revenue equation, when I sub in x as negative 10, my revenue equation looks like this, and the answer that I got in this case is 14,400. Next is when I sub in the revenue equation the value of 10, my value is 12,800, and when I sub in my revenue equation value of negative 15, my revenue would come out to 14,300. Clearly, by looking at this, we see this is the maximum revenue, and where do you see that maximum revenue is? When your x is negative 10. Now, when the x is negative 10, they wanted us to find out what fare should the railway charge to get the largest possible value. And the fare bracket is this. This is our fare bracket. When we look at this, this is our fare bracket. Now, on this fare bracket, we will sub in negative 10. So our fare bracket was 7 plus 0.10x. We will sub in x as negative 10, and from here we get to know that when I sub in this in here, I would be able to get $1, because 0.1 times negative 10, I'm going to get negative 1, which is going to be $6. So the fare that we should charge is $6 to maximize the revenue. And with this, we're done the question.